shed a tear for the final video. I might make this video like 50 minutes long. There's a lot to talk about, and I want to give you some extra examples. But so maybe we'll have a nice long one, long, dense, boring video to finish off the semester. Okay, so this is what we talked about in the previous video. Elasticity of demand is just, okay, what's the relationship between the relative rate of change of how many things we can sell, Q, quantity, divided by the relative rate of change of P, the price. How are these related? If I change the price, what's going to change more? The number sold or the price? Okay, what's changing more, price or number sold? And so if it's bigger than 1, the numerator is bigger here. The quantity is changing more than the price. And if the quantity is changing faster than the price, we don't want to increase the price. Increasing the price is having a big effect on how many people are buying it. We don't want that. That's going to be elastic. Okay, so if something is elastic, then we say that the revenue moves in the opposite direction of the price. So if demand is elastic at a specific point, then we can increase our revenue by decreasing the price. And inelastic goes the opposite way. Okay, this is the revenue moves in the same direction as the price. So if we're trying to maximize our revenue in a case where the demand is inelastic, we could do so by increasing our price. Okay, because it's inelastic if it's smaller than 1. It's inelastic if the denominator is bigger. Inelastic if the price can change faster than the demand. If I hike up my prices and pretty much a very similar number of people are buying it, well, yeah, I'm selling about the same amount of stuff, maybe a little less, for a lot more price. My revenue is going to go up. Okay, so that's another way of thinking about elasticity of demand here. Okay, there's some other ways of sort of talking about this as well. I wrote in my notes. I wrote in my notes a little note to myself says, leave some space right here. There is 0 space. All right, so we'll just kind of do it in the right next, a little bit below it, I guess. All right, so if it's elastic, that first situation, we want to decrease our price if we want to maximize our revenue. All right. This is like P affects Q a lot. So in terms of like situations where this might be the case is for like a lot of discretionary products is a term that we use. A lot of things that are discretionary products have elastic demand, where it doesn't really matter to the consumer which version of a product they use. Okay, so like, you know, maybe if, you know, maybe I'm going to the store one day and the company that I usually buy butter from, like tripled the price of their butter. Well, I'm probably just gonna, you know, buy something else. Maybe I'll buy some margarine. Okay, or maybe I'll buy something else. Recently, I've been using some Greek yogurt as a butter substitute as well in cookies. I said I was going to talk about cooking, and I am. So it's the consumers will buy something else instead a lot of times for something that is elastic. Okay, you double the price of the butter, maybe I'm going to buy something else. Okay, in which case an increase in price is going to greatly affect the demand. All right, lots of substitutions. So I use butter as an example, maybe not the best example, but it is one. If something is inelastic, as you can see behind my head, I'm writing inelastic. That is where the price doesn't affect the demand very much. So an example of inelastic, something that is usually inelastic, is the price of gasoline in the United States, where, you know, if the price of gas doubles, well, it sucks for the consumers because, you know, we got to get to work. All right. And a lot of us drive to work, especially in Wyoming, right? It's not really a place where it's like, okay, I'll just go over to the next town. I'll go walk to the next town for 50 miles or whatever, right? Not that bad, but you get the idea. So, you know, maybe gas is an example like that. Maybe I could go public transportation, but again, in Wyoming, there's not much public transportation. You're not going to probably ride your bike to Rock Springs from Green River, etc. Another one is textbooks. If your textbook producer decides, or your textbook publisher decides to double the price of your textbook in the next edition, in the 21st edition of the textbook, and they just double the price, well, if you have to buy the textbook, most people are still going to buy the textbook and just kind of be out of luck. You can also buy used textbooks. You can also buy older editions a lot of times. Most professors are okay with them. Feel free to check with your professor about older editions. Like I have a note in my syllabus for that. There is a lot of things, especially nowadays, that are changing this, but traditionally, textbooks are inelastic. If you're not just going to buy a different textbook, right? You're not going to just go buy a different calculus book and be okay. And again, there are some ways of changing this. Some other examples are like some luxury items. A lot of luxury items are inelastic. And these are all cases where the manufacturer, the seller, the producer, if they want to maximize their revenue, they can increase the price. All right. I can increase the price of my textbooks as much as I want, and I'll make more money because people are probably going to still have to buy it. Okay. So there's a lot of ways of thinking about elastic and inelastic demand. Here are some products that tend to be elastic or inelastic. Let's do some examples and use this. All right. Yes, my future, I'm going to stop teaching. I'm just going to start writing textbooks. Example 4, maybe. I don't know what number we're on. A certain metal has the demand function Q equals 100 minus 2P. Every increase, oh, hold on, let's get the units in here, where P is the price per pound and Q is demand in millions of pounds. Okay, so if I increase the price per pound, if I increase P by 1, demand is going to go down by 2 millions of pounds. So if I increase the price per pound of this metal by $1, we're going to lose 2 million pounds worth of demand. Okay, so that's the relationship here. That's what this demand function's all about. The relationship between the price I charge and how many people are going to buy it. The question is, Part A, what quantity can be sold at $30 per pound? Well, let's say, you know, I'm selling my metal and I want to sell it for $30 per pound. According to this demand function, which maybe we got from a variety of different ways, let's find out how many I'll be able to sell. So P, right? This is going to be P is equal to 30. And we want to know what Q is. So Q is going to be 100 minus 2 times P, which is 30. That's 100 minus 60. That's going to be 40. Q is 40. Remember that Q is millions of pounds. So if I charge $30 per pound of this metal, we can sell 40 million pounds. It seems like a lot of metal to me, but I certainly don't have 40 million pounds of metal. Anyway, maybe this, I really don't know anything about this, so I'm going to stop talking. Just keep going with the math. All right, so that's the relationship with the demand function and the price right here. Okay, so part B, determine E of P. Find the elasticity of demand function here. Okay, so E of P, remember we have that formula that I will give you, is P times F prime of P over the function. And there's a negative in there that I never said. So we just calculate this. We have a nice linear demand function here. Really happy to see this linear demand function because that means this is easy to calculate. We have negative P times the derivative of that demand function. The derivative of this function up here, that's just negative 2. Okay, it's that linear relationship. All right, divided by the original function, which is 100 minus 2p. And we can simplify again. And again, so many times, right? These negatives are going to cancel. We'll have 2p divided by 100 minus 2p. This is our demand function. This is our answer to part B. Sorry, not our demand function. This is our elasticity of demand function. This says at any price, here's the elasticity of demand. So part C, find E of 30 and E of 20 and interpret. So what is the, that's not how you spell that word. What is the elasticity at a price of $30 per pound and elasticity when the price is $20 per pound of this metal? And we're going to find both of those. And we're going to talk about what that means. All right. So we just plug in 30 and 20 into our elasticity function. So if you plug in 30, we're going to get 2 times 30 divided by 100 minus 2 times 30. Plug that into a calculator. You're going to get 60 over 40, which is 3/2, I believe. We'll talk about what that means in a second. You have 20. You just plug in 20. And you get something like this. That's 40 divided by, looks like subtraction, it's multiplication. 40 divided by 60, that's 2/3, I believe. Again, we could also notice a couple things here. So when it says interpret, it's kind of an open-ended question. It's not actually a question, it's a command, suggestion maybe. There's no question mark. Really losing it today, it's getting too late. When price is $30, we're elastic. The demand is elastic. This is a number that's bigger than 1. When we're charging $20, the demand is inelastic. It's less than 1. Okay, so that's one thing that we can say. We can say, okay, this is elastic right here. This is inelastic over here. We can also connect it with remembering the definition. Elasticity has to do with, okay, what's the relationship between the relative rate of change of the quantity and the relative rate of change of the price? Here, the relative rate of change of the quantity is changing faster than the price. So if I increase the price, the demand goes down by about 50% more than the price is changing. Okay? So there's a larger change in demand with a change in price. The change in demand is faster than the change in price. There's a whole lot of different ways that you can answer this question. Okay? Inelastic, another way of saying it. Remember, another way that we interpreted elasticity of demand, right, is if something is inelastic, that means the revenue is going to move in the same direction as the price. So if it's inelastic, if we want to maximize our revenue, we should increase the price. to maximize revenue. A lot of ways of interpreting this. This is elastic. We should decrease the price here to maximize revenue. We should increase the price here to maximize revenue. So if we really just care about maximizing our revenue, we should charge somewhere between 20 and 30. At that middle point where it's neither elastic nor inelastic, when the elasticity is 1. The critical point for these revenue functions is going to be when the elasticity is 1. Another way of approaching these maximum and minimization problems with demand functions. All right. So let's do one more problem, really tie it all together. Example 5. Let's say that Q is going to be some function 10,000 divided by P plus 50. Whoa, what is going on down here? This fraction bar really started going south. All right, and then minus 30. This is the relationship between the price we can charge P and the number or quantity that we can sell Q. So if that's it, find E of 150 and use this to determine whether we should increase our price to charge more than 150. If it's inelastic, we want to increase our price. If it's inelastic, then changing the price doesn't change the demand too much. We'll make more money. Okay? So, elasticity of demand is negative P times F prime of P divided by F of P. Calculate, we simplify, we plug in. Maybe we don't simplify too much if we don't have to. So it'll be negative P times the derivative. Derivative here is not going to be super pretty. Off to the side, we could write this as 10,000 times P plus 50 to the negative 1 plus 30. We could write it that way. It would be incorrect because it's supposed to be minus 30. There we go. So we'll use a power rule here. And strap yourselves in. So negative comes down, negative 10,000. Inside stays the same. Subtract an exponent. Derivative of minus 30 is 0. This is our numerator. Denominator is just the original function. 10,000 times P plus 50, the negative 1, minus 30. So again, negative times a negative is a positive. Don't write this down if you are trying to keep up with my fast math. We cannot cancel here because we can only cancel if the factor exists in the numerator and the denominator. The denominator has that minus 30. So we actually can't cancel almost anything. There's some things that we can cancel here. We're just not going to do it. All right. Canceling here is just probably going to make things worse. Unless you're really, really a cancel prodigy. Okay, so we could simplify a little bit by multiplying the top and the bottom by P plus 50 squared, or we could just plug in right now. Because we don't care about the function here. We just care about the function value at this point. So E of 150 is going to be 150 times 10,000 times 150 plus 50, the negative second power, divided by 10,000 times 150. We're just plugging in 150 for all the P's. And then you type this into your calculator and you be very careful to make sure that you do it correctly. Again, if you want to see, a lot of times I use this really fancy calculator called google.com. We just type it in here. Whoa, we are showing the wrong thing. This always happens. It has to do with how I capture my iPad. Is it this one? There we go. Again, just be careful with your parentheses. So it's going to be the numerator is in parentheses. That's 150 times 10,000 times 150 plus 50 raised to the negative second power. That's our entire numerator right there. We're going to divide that by the denominator. Okay, the denominator is 10,000 times 150 plus 50 raised to the negative 1 minus 30. That's the entire denominator. Okay, you plug that in, whew, we get an answer, 1.875. So that's the elasticity of demand. The elasticity of demand is bigger than 1. We say this is elastic. If elasticity of demand is really big, it's elastic. If it's smaller than 1, it's inelastic. So determine whether we should increase our price. It's elastic, which means that quantity, it's a big number. Relative rate of change of quantity is on the top, price is on the bottom. The quantity is going to change a lot more than price. So if we increase our price, demand is going to take a big hit. Okay? Which is bad for revenue, right? If I increase the price, people are going to buy a lot less of it. This is not a good idea. We should not charge more. Okay? So since it's elastic, we should not charge more. In fact, we should actually lower our price. So do not increase price. Again, we did have that property at the beginning of the day that said elastic means that revenue moves in the opposite direction of price. So an increase of price is a decrease in revenue. A decrease in price is an increase in revenue for elastic. Okay? So we do not want to increase the price here. We increase the price here, we're going to lose too many customers. It'll be a bad deal. Okay? This should be everything for elasticity of demand. You'll have some extra problems on the review that are really just stolen from the homework, like all of the reviews that I make. Good luck. Don't hesitate to ask me if you have questions. I said it'd be a 50-minute video. I'm sorry. It's only 22. And this is why this section is an entire week. And we're only doing one section this week because I knew it'd be a long one. Okay. Good luck. Ask questions. You have a final, but not this week. This week is just a quiz. Final will be the week after that. And yeah, this is the last calculus video I get to record for you guys. So enjoy.